Okay, we have here another integral from the MIT integration bee 2024. This one, problem 12. We have the integral of cosine of x to the x, natural log cosine x minus x tan x dx. Okay, the real problem sticking out on this one is just this thing right here. Very unusual, and we can't really deal with it this way, especially just we have an exponent x. We almost always want the base to be e. So what I need to do is something to manipulate this. And what we can do is the same thing, like what I can do here is something similar to like when you just have the integral of something, let's say you have like 2 to the x. What we want to do is convert this and get the base to be e. So what we can do is if we have something, forget about 2, but if we have a to the x, I can take this, I can write a as e ln a. And then what we can do with exponent properties is just kind of distribute this in here. And so we can write this thing as e to the x ln a. So now for this, our a is a constant value. Well, our situation's a little different. Our a is cosine x, but it's still going to work the same way. If I just kind of set this up and write this as cosine of x to the x, then we can just kind of use this, and I can write this as e ln cosine of x, right, to our exponent x, but doing the same thing, distribute that in. I can write this whole thing as e to the x ln cosine x. But then as soon as we do this, things are starting to look better, because you just look at this, we have ln cosine x here. Well, now what's going on here is starting to make more sense. So what I'm going to do is let's just take this, plug it, I don't know what just happened to this marker, but we're going to take this, we're going to try to plug it back in here into our integral, and I'll get a new marker. Okay, so now just using this thing that we found from the previous board, we went from here to here, and we just made this update. But now at this point, what I can try to do on this is just a u substitution. So what I'm going to do is I'm going to call this my u. So we'll go over here and we'll set this up. We'll say u is equal to e to the x ln cosine x. Then I'll take my derivative on this. So first the derivative is going to be just e, just the same thing as we have base of e. So it's going to be e x ln cosine x. But then we need chain rule taking the derivative of this thing. So when we do that, then again, because we have two things, we're going to need to take the product rule. So derivative of x just 1 ln cosine x. And then for the second part, we'll have x. Derivative of ln cosine x is going to be 1 over cosine x. Derivative of cosine x is going to be minus sine x. And let me kind of squeeze in a dx right there. But then I can just rewrite this a little bit. So we'll bring down this ex ln cos x. This thing's just going to become ln cos x. This minus sign I'll bring here. So we'll write this as minus x sine x over cosine x. This is just tan x. And again, I didn't leave room for the dx. But then look what just happened. This whole thing right here, this is actually our whole integral. So the whole integral becomes just du. So what I can do is rewrite this and just look at it as 1 times du. So just integrating that, we just get u. U is this thing right here. But when I write the final solution, this thing here is this. So we can go backwards to what we had originally. So our final solution is just going to be this. We get cosine of x to the x plus c, and that's it. Okay, so I guess the moral of the story is always get the base to e, but also take the derivative of this thing and find out what it is, because then maybe it'll just simplify the whole problem. Okay, there you have it. Good problem from MIT 2024. Thanks everyone for watching. Have a good day.